So I recently found out about this game called Mini Metro, and this is um, this is how the game looks. I mean, you can just go on App Store and find it out. Apparently, it's a 10-year-old game, but I just found out recently. So there are these dots that appear, which are stations where there are people who want to go to a different shape, and you connect them together and you make a metro line, something like this. And while I was playing that, I was wondering that how hard it might be to build a game like this in Cloud Code. And before all this AI and Cloud Code, Copilot, and all of that stuff, like I think 2 years back, it would be quite difficult to think of just trying to build something like this on a whim, because while just drawing the lines and all might not sound all that difficult, but there's a lot of dynamics in the game as to people moving around and all of that. But anyway, like I mean, it gives a lot of confidence to jump into something like this with Cloud Code and try if you can do it. And that's what I did about 4 hours back. And here's where I've reached in 4 hours, by the way. So in fact, I just started off with trying to even figure out how I will make this game, and this is where I have reached. Just to just show where it is. Let me just maybe move this thing out. Uh, yeah. So just want to move this thing away for like yeah. Um, that's how the game starts. There is a seed generator. This is something that I just figured out how to do as well, because I've seen it in a lot of games. So basically, given a seed, let's say 408, you generate, it generates this map. Another seed 721 generates this map. So if I use 720, this map 721, it'll exactly generate the previous map back again. So in this game, how I have thought of it is that you can start with a seed generated map. This is something that I've seen in games like uh, Transport Fever, where you can generate a map based on a seed. I think City Skyline also you can do like that. And I wanted to make a game, a two-dimensional, like a game as simple in UI like Mini Metro, but kind of dynamics very similar to City Skylines or Transport Fever. So anyway, there are a couple of things that you can generate. There are archipelagos where there is water all around and there is land. So archipelagos like this. There can also be like pretty separate islands and all that stuff. Or you will have ones where there's a river inside your city. Most of it is land, but there's a river that going through the city. Could be going through any direction. Um, so that's one thing. The other thing is that whenever you generate a map, it has a residential density. So there are places where there are more residential places, and there's an office density. These two things might not have the epicenter at the same place. You can compare the both together and see the residential and office both are there here, but this place only residential. This place also only residential. Um, why the residential and office density thing? So that when we place the stations there, more people will spawn in the residential areas in the morning when they want to go to the office, and more people will spawn at the office places and they want to go back to the residences. So to create that dynamic, I thought I will add this thing as a thing as well. But anyway, let's start. So once we start, what we can do is you can add stations. Let's say residential places are here. You can add some stations here. More people will be spawning around these areas. And then if we go on the office map, some people will spawn here. So these are the office people, maybe, yeah. So stations run. We can add some lines here. Let's say green line goes from here to here to here to here, and then there is maybe magenta line which goes from here to here to here. Okay. Um, yeah, and these maps and these lines that are generated. So this is also something that I kind of knew about it. I had gone to the Transport Museum in London and knew about this guy called Harry Beck, who designed the first London tube map of this type, generated like in this shape and everything. This is like the London tube map, famous for these lines in that format. So I was just wondering, like, how that is generated, and I figured out that there is a logic called octilinear rendering, which is used for making lines like this, where the lines are either vertical, horizontal, or they follow the diagonals. And these things are called knees, where the line bends, and then there is a logic to where the knee bends, kind of a thing. Anyway, I'll talk about all of that when I go into the delve into the code. So if we start the simulation, so the simulation starts. There are a couple of speeds at which you can go, 12x to 1x. Have gotten these little train bogey kind of things built as well. I think the next step that I want to do is I want to um, make people spawn here based on, like, residential areas will spawn more people in the in the morning, office areas will spawn more people in the evening, and then they will go to their destinations and stuff like that, and they might need to change their interchange, so maybe some pathfinding logic there as well. So yeah, I mean, that's kind of how I built it. So and how I got started with it was, like, I actually went to uh, Cloud Code and say that this is what I want to build, like, write the technical specs for a game. This, I will have a map creation logic, some what kind of properties the map will have. There will be some densities for the offices and all, and how to create the stations and lines trees of the game. And I mean, in first go, it gives quite a good result around, like, what could be the different models for the train, the station, mm, the grid, the boxes, all of that stuff. How to generate water. It gave a bit of an initial idea. I had to prompt it through all the logic afterwards, and then the passenger spawning system. It has given some ideas about how to do that for different times of the day, in the morning rush, evening rush, and how to do the pathfinding for the people going through the station. So that's like a good initial thing to start from, and I did the same with Gemini as well, right? So here also I'd asked Gemini kind of the same question. I think Gemini's answer was kind of better in the sense that some of the procedural algorithms, like how to create a river versus, like, there's a drunkard's walk algorithm which creates like the river through the map, how to create archipelagos, how to create the density layers, then it should not be completely random as well, the density layer. Like, there's going to be clusters where the density is high, so one square with the density almost 100, the next square being 0. It's not like that. It'll be like, it'll disperse slowly out from high density to low density, all that stuff. And it gave me a little bit of more ideas, like how uh, the edges basically work for the lines, some of the simulation mechanics. This is more of like explained to me like a mathematician kind of way. The Gemini answer was, the cloud answer was more like, here, let me write the code and show you how to do it. So I started off with that, and then it was fun prompting Cloud Code, Copilot, Gemini. I used all three for parts to build it. There is the game state itself, which contains the seed, the map, the stations, the lines, and when it starts simulating, then the number which keeps like going up. Um, uh, the grid, which stores the information about the grid. The game is saved, by the way, so like, if I every time I refresh the page, it stays. You can save your game, you can restore your game, the stations, the trains, the models for that, and then there is the generator for the map, which is based on that seed thing. So given the specific seed number, it will generate the same map every time. It has a bunch of things like you know generating a river map versus, and inside that, there you can generate a single river map or a branching river map or two separate river maps. So that I had given some probability distribution that for 50% of the cases it will have a single river, for 25% of the cases it will have a branching river where two branches merge into one river, and for 25% of the cases it will have two separate rivers on the map. Then drawing the river, drawing a meandering river is one that goes like this, and all of that stuff. I've not written any piece of code myself by hand, like it's all been prompting, but I have sometimes just asked exactly what to do. Like, I've sometimes written the mathematical formula and asked the model to do it. So it's fun. I don't think it could have been done in like 2 to 3 hours kind of time if I had actually written any code by hand. Um, but yeah, I mean, I feel like you do. you do have like a lot more velocity doing it this way. Like you can tell in plain English exactly what you want, and then model just keep generating stuff. Then there's the map picker screen, the vector builder screen, all of that. Interestingly, I also built it using the library called pixie.js, something I'd never used before. This is like I just first time used it, and I actually had asked Gemini about like what gaming engine or what 2D rendering engine to use, and it suggested pixie.js, and I opened it and I saw the getting started, and I saw some of the showcase ones, and I thought it was actually good. It had good examples. It was easy to get started with. Although, I mean, I did not need to get started with myself. Like I did not need to install pixie.js in a way myself. I did the npm install, and then like using pixie.js was completely done by Cloud Code, reading the documentation of Pixie and doing it. But I think it's a good gaming engine to do this. It's a 2D WebGL engine which uses Canvas. So yeah, kind of there's that for now, and let's see where it will go from here. Um, the line algorithm was definitely like fun to build. Like it required iterating a bunch of times. So how these lines are created. So it, it figures out like normalizing the angle and then snapping it to the angle, and then also the fact that how to calculate the points at where it will bend the line every time for this knee point. And then I also had a calculate optimal knee point thing, which makes this way that if I just reset and start with a new map and put some station, just to show. So I go from map. So if I go from here to here, and then if I go and connect it to this, the line changes a bit because it realizes that it is possible to just go through directly without doing a bend here. Similarly, like if I make another one like here to here, it uses this bend. But then if I go here, and then if I go here, it will bend different way so as to keep the shapes smoother rather than like go into an edge and then coming back through the same way. Rather than doing that, it will just use the curve properly. So this was like you say, this bend gets redone because it snaps the knee back from like the knee was here, and the knee goes back one level here. So I mean, there's a lot of stuff to do there, and if I were doing it kind of manually, it obviously takes a lot of time to like I can think it through that the knee needs to be here, but then to actually do that math myself line by line and fixing it, it would have taken me many hours, I think, versus like just asking the LLM very specifically that when I connect it to another dot, if the previous dot the line can be made more smoother, then snap the knee to the alternate position. And it does that. So that's obviously so when you make a line, like you connect this to this, so the knee could be here, the knee could also be here, like it could go up first and then right, or it could go right first and then up. Now, for now here you pick any one of the options, but then if it connects to another path somewhere else, then it could pick a different snapping point so the line is smoother. I'm sure like any digital tool that people use for building these things, like I'm sure that the councils, like the city authorities who build maps for metro in cities like London and Paris and New York and then Seoul and Tokyo and all of these places, I'm sure they use some tool which does the same thing, right? They help you build these things more easily. I'm sure they have a digital designing tool which does that. Think that you can come up with this logic, like you can just verbalize your logic in English, and the code gets generated very fast. It's really fun. I will continue building this game for sure, and see where it goes. I think there's a lot of complexity that can be added. I want to add a dollar cost to this as well, like when people go from one destination to another destination, depending on how long they are traveling, they will pay some money as ticketing fee. And in the beginning, when you design the map, you will invest a lot of money into how many stations you build. And I think I will try to make the game about like in how less number of days or you reach profitability basically. you can recover the cost of the investment into all of your stations and lines. So you can make too many stations, you will start off at a much larger negative balance, and it will take you more time to recover all the cost of the tickets. Whereas if you make an efficient map, then you put the stations exactly at the hotspots, and you get more people coming in, and you recover the cost more quickly. And kind of exactly like the model how city mapping, city planning games like City Skylines and Transport Fever, these kind of games work. So that's the idea. So this is like 3 to 4 hours of work has gotten till here. I think another 4 or 5 hours of work we might have kind of like a finished version of it. For now, it is live somewhere on championswimmer.in/metromap.io if you just want to go and try it out at the current stage it is. Feel free to do that. Yeah.